All right, so here's our third part for the lecture on water quality and water pollution, chapter 18. So in the last lecture, we were talking about the problems that are still out there. How do we make sure our watersheds are clean and safe and healthy? And really trying to focus on those top three sources: the sediments, the nutrients, and the pathogens. So groundwater can get polluted in a variety of different ways, as this little picture shows us here. All right, so again, pollution gets into groundwater from a variety of ways. Anything we do on land eventually can get into the groundwater, whether it's I'm spraying my fields, or I have surface runoff, etc. All that stuff can eventually trickle and work its way down through the rock layers, through the soil, and reach the aquifer, those beds of water that we then tap and use for drinking water sources. So that's why we want to protect and keep an eye on surface water, or the surface, and what we do with pollution on the surface so it doesn't get down there. Sometimes we're injecting wastes deep into the earth, this injection well over here that people use, like, well, let's just inject the waste deep into the earth so we don't have it on the surface. But are we injecting it right into our aquifer? So now you're polluting the aquifer, and then when the aquifer gets used as a source of drinking water for a community, they're bringing that waste back up. So in those three issues of sediment, nutrients, and pathogens, we want to think about how do we address that at the surface level to protect the water underneath. Now, with the ocean pollution, coastal zones have the greatest problem. Those coastal zones, the estuaries, the bays, the reefs, all these areas are close to land. So when we pollute the land, eventually that stuff washes down into the coastal areas. And unfortunately, frustratingly enough, those coastal areas are polluted and contaminated with heavy metals, toxic chemicals, pathogens, sediment's a huge issue, etc., because everything we do on land eventually makes its way to the ocean. And then you get that accumulation, the magnification, all of those problems continue to increase when you get all these rivers converging at the coastal areas. So when we look at ocean pollution, there's really four big primary sources of pollution for the ocean. The first one, what we were just looking at, discharge from land. This is basically runoff. Anything that we do on land washes into the ocean eventually. Ocean dumping. Some countries don't have good sanitation practices, so they load all their trash up onto barges, haul it out into the ocean, and just dump. And then it gets caught in the ocean. So here's your coastal area, here's your land, give you a little house, and you take your boat out into the ocean and you dump your trash. Well, then that trash eventually just washes around in the ocean and follows the ocean currents and can wind up washing up shore, sometimes thousands of miles away from where it was originally dumped. Ship trash, byproduct. People out on the boat, cruising around, stuff blows out, winds up in the water. Unintentional usually, or maybe small scale intentional, like people throwing trash out of their car window. But we see stuff like that in the ocean all the time. Bottles and plastic and paper and all sorts of things that shouldn't be just discarded randomly in the ocean. And then the fishing byproducts. This poor seal over here. You look at this poor guy, not happy. It has a fishing net wrapped around its neck. So depending on the fishing practice, sometimes a lot of their supplies get discarded in the ocean and can lead to some major, major problems of pollution in the ocean. So a lot of this has kind of accumulated off the coast of Florida right now, 2018, leading to these algae blooms. So I encourage you guys, jump on to Google Florida algae blooms. Take a look at a news source And take a look at this issue. It is massive. It's a major health issue for a lot of people. They're getting sick because of this stuff, degrading their water quality. It's also a major economical issue. I'm not going to Florida for spring break because I can't swim, I can't snorkel, I can't go to the beaches, I can't go to the reefs. I'm not going out fly fishing, I'm not going out charter fishing, etc. They're not harvesting fish to sell, etc. Huge, huge issue because of water pollution that they're dealing with right now. So it'll be years before we see the full recovery from this issue. So the goal is figuring out ways to control water pollution. And one of the best ways, big red star here, one of the best ways to avoid water pollution or minimize it is let's stop making the products that are causing the problem. Stop producing pollution. If we have to, don't release it into the environment. So gasoline, notice these are all unleaded. Years ago, lead was a part of gasoline. We know the problem with lead. It got banned. Made a huge difference. That's a great success story. Let's take lead out of gasoline and find alternative ways to make fuel. Let's take lead out of paint. We know all the horrible things that lead paint does. Let's get rid of it. Things like DDT, ban it. Can we ban this globally and get rid of DDT? Makes a huge issue. That is the starting point with a lot of this. Let's minimize production of these pollutants and, if all possible, eliminate them from being released into the environment. So we start there, but then we also look at other ways of helping deal with water pollution. Land management. All right, we talked earlier, non-point sources are still a huge problem. Trying to identify them and trying to create legislation and practices that minimize pollution from non-point sources. So when we look at the land management, we have 4 primary land management areas that we're working with. Agriculture being number 1. This is the biggest problem. Can we encourage filter strips? Can we use different plants for bioremediation? There's different trees that actually suck up pollutant, take toxins out of the environment. Can we plant a bunch of those in your filter strip to minimize the impact you have on that aquatic system? When we talk about commercial feedlots, those confined feedlot operations, can we create legislation about the containment pits for the animal manure and make sure that follows safe environmental protocols, so that way those pits, the gigantic pools of poop, don't leach out into the environment and wind up in the water system. All right, so agriculture is our biggest one, trying to work with it. And a lot of people are supportive. There's just a lot of challenges here. Number 2 is urban runoff. Now with urban runoff, you fertilize your yard. It rains. That washes down into the street, goes into the gutter. That carries it into the sewage system. Where does that stuff go? Can we do things like greenways? Now, greenways are just strips of plants that will slow water down and grab those nutrients and prevent them from reaching the drainage system in a city. Can we do that kind of stuff? Can we encourage residents to decrease their fertilizer use? Simply don't fertilize as much. What you're doing usually is over-fertilizing. Is it necessary? Do we need that lush, rich, green, lawn with just only grass in it? Or is it okay to have other plants growing in the lawn, different types of grasses? Can we change our practices there? And concrete actually has gotten really, really cool. Traditionally, concrete, solid, flat, water hits it, slides over to the surface, goes towards the gutters, gone. So that increases velocity, can create some problems with runoff and erosion. Water-absorbing concrete has been developed. Solid enough, structurally sound enough to support vehicles, but water actually percolates through the concrete. So it absorbs the water and allows the water to percolate down into the water table instead of just sliding off the surface of the concrete and winding up wherever it's being directed. So incredible new technology to help us work with water pollution. The other two areas are construction sites. Now, drive by a construction site and hopefully when you look out there, you're going to see these, what they call silt fences. They're a mesh fabric with some stakes to hold it against the ground, and they're placed along the edge of the construction site to help prevent erosion. So as water comes through this field, it rains, if water's going this way, when it hits the silt fence, it traps all the silt. The water itself can keep running through and into the grass, but it decreases erosion. The other style over here is this. It looks almost like a big, gigantic sock, usually about foot and a half in diameter. It's a sock of straw or these various materials in here. And the goal is as water is flowing, it hits that silt fence or silt sock. The water slows down, water goes over the top, but what it does is it leaves behind the sediment. So that little sock thing, actually the goal is it traps all the sediment, and the sediment builds up on this side so it doesn't wind up going all the way downstream. Depending on the size of the project and the elevation of the land, they may put 1, 2, 3, there's another one down here, you can almost see it, 4, etc. There's standard protocols for how many they need for so many feet of erosion control. But hey, slow the water down, prevent erosion. It's a good thing in the big picture. And then the last area is what we call land disposal or waste disposal. Landfills. Designing landfills. Okay, so we're talking about landfills here. Designing landfills to be more effective. Early landfill designs were just pile all your stuff up. There's all your trash. And sometimes they said, well, let's throw some dirt over the top of it, bury it under dirt, and you're good to go. Well, when you have pollutants in the trash and it rains, those pollutants often leached out. Well, there's new landfill designs to try to ensure you don't have pollutants leaching out. Sometimes they actually recycle the nutrients from the decomposition. Decomposition often produces gas, methane. Can we tap that methane as a fuel source? Things like that. So working with industry to design landfills that are specifically going to work with decreasing pollution, water pollution, and controlling the potential for runoff there. Bottom line is we make a lot of trash as a species. It's got to go somewhere. Some of this stuff doesn't ever disappear. How do we control that and keep it out of the water sources, the water systems? Right. So the last lecture, we'll wrap up in the next lecture with human waste disposal. So, and that's kind of one of the big issues. We all create this, we all contribute to this. How do we manage waste disposal, human waste disposal? Because if you remember early first part of this chapter, we talked about one of the main infectious agents, main sources of waterborne pathogens is human waste. E. coli and different coliform bacteria, viruses, pathogens, it's coming from us. So we want to make sure we have properly designed waste disposal systems for human waste to minimize potential exposure to human pathogens. All right, so we'll wrap that up in the last lecture.